Good morning students, this is Latif sir. In this video I am going to start the chapter 8 of class 11th chemistry. The topic is redox reaction. Redox reaction. You have already studied in lower class that redox reactions are those reactions in which both oxidation and reduction reactions take place simultaneously. In which redox reaction are those reactions in which both oxidation reaction and reduction reaction take place simultaneously. So first you have to know what is an oxidation reaction and what is a reduction reaction. So here I have given the definition of oxidation and reduction. You can define oxidation and reduction in terms of electron, in terms of hydrogen, in terms of oxygen. Okay, and these three definitions are given in the syllabus. Okay, so first definition of oxidation in terms of oxygen. So in terms of oxygen, oxidation means addition of oxygen to an element or to a compound. Or you can also define oxidation in terms of hydrogen, like the removal of hydrogen from a compound is also known as oxidation. So addition of oxygen or removal of hydrogen is called oxidation. For example, in the reaction when magnesium reacts with oxygen, it gives magnesium oxide, MgO. Here magnesium combined with oxygen, so it is oxidation reaction. Similarly, when hydrogen sulfide reacts with water, it will give hydrogen sulfide reacts with oxygen, it will give H2O plus sulfur. It is also oxidation reaction. Okay, and you can also define oxidation in terms of electron also. Oxidation is the loss of electron. Loss of electron means oxidation. Oxidation is the loss of electron by an atom or ion or molecule. Okay, for example, when zinc loses 2 electron, it is converted into Zn2 plus. Okay, so zinc to Zn2 plus 2 electron, it is an oxidation reaction. Okay, because zinc loses 2 electron and it is converted into Zn2 plus ion. And one more definition is given here: oxidation in terms of oxidation number. Oxidation includes increase in oxidation number. So you have to know what is oxidation number. Later I am explaining what is oxidation number. Okay, so oxidation means addition of oxygen or removal of hydrogen or loss of electron. Okay, or increase in oxidation number of an element in a compound is also known as oxidation. Now see different types of reduction, different definitions of reduction. Reductions are just opposite of oxidation. Okay, so the definition of reduction. So reduction means addition of hydrogen to an element. Addition of hydrogen to an element or compound or the removal of oxygen from a compound is known as reduction. Addition of hydrogen to an element or compound or the removal of oxygen from a compound is also known as reduction. For example, when hydrogen sulfide H2S reacts with chlorine, it will give 2HCl plus S, 2HCl, 2 hydrochloric acid and 1 sulfur. So in this reaction, from H to S, removal of hydrogen take place from H to S. So this is a reduction reaction. Okay, similarly when Fe2O3 ferric oxide reacts with carbon monoxide, it will give Fe and 3CO2. So this is also a reduction reaction, because removal in the first case hydrogen sulfide reacts with chlorine, so chlorine combined with hydrogen, so this is the addition of hydrogen with chlorine, so this is a reduction reaction. Okay, reduction of chlorine. And in second reaction, Fe2O3 plus 3CO implies 2Fe plus 3CO2. Here from Fe2O3 removal of oxygen take place, so this is a reduction reaction. Okay, so you can define reduction in terms of removal, in terms of hydrogen and oxygen, addition of hydrogen to an element is known as high reduction, and removal of oxygen to a compound is known as removal of oxygen from a compound is known as reduction. Now see, in terms of electron, reduction is the gain of electron by an atom. In terms of electron, reduction is the gain of electrons by an atom, ion or molecule. Okay. For example, when copper 2 plus Cu2 plus accept 2 electron, it become Cu2 plus 2 electron to Cu. This is a reduction reaction, because addition of electron or gain of electron by an atom or ion or molecule is known as reduction. And you can also define reduction in terms of oxidation number. Reduction involves decrease in oxidation number. Okay. Now see, oxidant and reductant. Similarly, oxidant and reductant. First, it is written oxidant, or also called oxidizing agent. An oxidant or an oxidizing agent is a chemical substance which can accept one or more electrons and causes oxidation of some other species. Similarly, reductant or reducing agent is a chemical which can lose one or more electrons and causes reduction of some other species. Okay. That means reducing agent can reduce other substances, and oxidizing agent can oxidize other substances and itself reduce. Reducing agent reduces other substances and its reducing agent itself reduced. Okay. Now see, oxidation number. What is an oxidation number? Oxidation number is the charge on an atom in a molecule. Okay, so it is defined, the oxidation number is defined as the charge in which an atom appears to have when all the other atoms are removed from the compound okay. So oxidation number is defined as the charge in which an atom appears to have when all the other atoms are removed from it as ions, and it may be positive or negative. For example, in MgCl2, the oxidation number of magnesium is +2. Okay, in H2SO4, the oxidation number of sulfur is +6. Okay, the oxidation number of sulfur in H2SO4 is +6. Okay, so an element have different values of oxidation number depending upon the nature of the compound in which it is present. Okay, same element can have different oxidation number in different compound. Now, oxidation number of an element may be a whole number. It may be positive, negative, or fractional, even 0. Now see, important points for determining oxidation number, or how to determine oxidation number. You have to follow some rules. Okay, so first point, the algebraic sum of the oxidation numbers of all the atoms in an uncharged or neutral compound is 0. The algebraic sum of oxidation numbers of all the atoms in an uncharged or neutral compound is 0. Okay, and in an ion, in case of ion, the algebraic sum is equal to the charge on the ion. Next point, all the elements in the elementary state have oxidation number 0. All the elements in the stable state, like oxidation number of oxygen in O2, oxidation number of nitrogen in N2, oxidation number of sodium in sodium metal, oxidation number of potassium in potassium metal, oxidation number of chlorine in Cl2, oxidation number of sulfur in S8, oxidation number of phosphorus in P4. All all this oxidation number is 0. Okay, so all elements in elementary state or in stable state have oxidation number 0. Okay, so oxidation number of helium is 0, oxidation number of chlorine in Cl2 is 0, oxidation number of sulfur in S8 is 0. Next, as fluorine is the most electronegative element, it always has oxidation number of -1 in all of its compound. So oxidation number of fluorine is always -1 in all of its compound. Next one, in compounds containing oxygen, the oxidation number of oxygen is -2. Oxidation number of oxygen in maximum cases it is -2. In maximum compound the oxidation number of oxygen is -2, but in peroxide the oxidation number of oxygen is -1. Peroxide means oxygen oxygen linkage. If oxygen oxygen linkage is present in a compound, then oxidation number of each oxygen is -1 in peroxide linkage. Okay, and oxidation number of oxygen generally is -2, and oxidation number of oxygen in peroxide such as in sodium peroxide Na2O2, in hydrogen peroxide H2O2 is -1, and oxidation number of oxygen in OF2 in O2F2 is +2 and +1 respectively. Next, point number 5, in all compounds except ionic metallic hydride, oxidation number of hydrogen is always +1, except in metal hydride like in NH, in MgH2, in CaH2, in lithium hydride. In this compound oxidation number of hydrogen is -1, but in maximum cases oxidation number of hydrogen is +1. Okay. 6 point, oxidation number of alkali metals like sodium, potassium, cesium. Oxidation number of alkali metals, all alkali metals, lithium, sodium, potassium is always +1, and oxidation number of alkaline earth metals is always +2, like oxidation number of magnesium, oxidation number of uh, calcium. Oxidation number of these elements in compound is always +2. Oxidation number of alkali metals is +1, and oxidation number of alkaline earth metal is +2. And oxidation number of metal in amalgams is 0. Okay, and point number 8, in case of a coordinate bond, it gives +2 value of oxidation number to less electronegative atom and -2 value to more electronegative atom when the coordinate bond is directed from less electronegative atom to more electronegative atom. In case of coordinate bond, it gives +2 value of oxidation number to less electronegative atom and -2 value of oxidation number to more electronegative atom when the coordinate bond is directed from less electronegative to more electronegative atom. But if coordinate bond is directed from more electronegative to less electronegative element, then its contribution be 0 for both the atom. And for p block element except fluorine and oxygen, highest oxidation number is equal to their group number, and lowest oxidation number equal to the group number -8. Now see some example. Using this following points, you can calculate the oxidation number of different element in a compound. So first calculate the oxidation number of chromium in K2Cr2O7. Okay, in K2Cr2O7, it is a neutral compound, so charge of each individual ions, the charge charge of individual ion will be equal to 0, and you know potassium always have +1 oxidation state, and chromium, oxidation number of chromium you have to calculate. So 2 potassium, 2 into 1 plus for 2 chromium, and you have to calculate oxidation number of chromium. So for each chromium, here I have assumed that oxidation number of chromium is x, so 2 into x for 2 chromium, and I have told oxidation number of oxygen in maximum cases is -2. So 7 oxygen, so 7 into -2, so 2 into 1 for 2 potassium, plus for 2 chromium 2 into x, I don't know what is the oxidation number of chromium, plus plus 7 into -2, total sum is equal to 0. So 2 plus 2x minus 14 is equal to 0, x is equal to plus 6. So in this compound, chromium has each chromium has plus 6 oxidation number. Okay, now calculate the oxidation number of Fe in FeCN whole 6. Same process, FeCN whole 6, 4 minus, it is an ion. So total uh, algebraic sum of charge of different atoms in this compound will be equal to -4. So, okay, so FeCN whole 6, you have to calculate oxidation number of Fe. I don't know what is the oxidation number. Here I have assumed that oxidation number of Fe is x, and you know oxidation number of cyanide is always -1. So x plus 6 into -1, because 6 cyanide is present in FeCN whole 6, 4 minus. So x plus 6 into -1, so x minus 6 is equal to the charge of the ion. Okay, is equal to -4. So x is equal to +2. So in this compound, the charge on Fe is +2. Oxidation number of Fe is +2. Okay, now calculate oxidation number of sulfur in Na2S4O6. Na2S4O6. Okay, Na2S4O6. In Na2S4O6, structure is this one here. Structure is given. In Na2S4O6, total 4 sulfur atoms are there. Okay, and 2 sodium atom, and for each sodium atom oxidation number is +1, for each oxygen atom oxidation number is -2. So 2 into +1 plus, and 4 sulfur atoms are there, and you have to calculate oxidation number of each sulfur atom. Okay, so for 4 sulfur atom, I have assumed that oxidation number of each sulfur atom is x. Then 4 sulfur atom, 4 into x, and 6 oxygen atom, so 6 into -2, and total compound is neutral, so 2 into 1 plus 4 into x plus 6 into -2, total charge is equal to 0. So on an average, for each sulfur atom oxidation number is 5/2, but this is not actual oxidation number of each sulfur atom. Okay, this is not actual. Okay, so what is the actual oxidation number? Oxidation number of this sulfur atom of this sulfur bridge is 0. Okay, oxidation number of both this sulfur atom is 0, and you have to calculate oxidation number of these two remaining sulfur atom. Okay, and oxidation number of this remaining two sulfur atom is +5. Okay, this is +5, and this sulfur is also +5. Okay, so two type of sulfur atom is present in Na2S4O6. Okay, and oxidation number of sulfur bonded with coordinate bond is equal to oxidation number On of sulfur bonded to coordinate bond is +5. So oxidation number of these two sulfur atom, oxidation number of these two sulfur atom, coordinate bonded sulfur atom, is +5, and oxidation number of these two sulfur atom is 0. Okay, so two type of sulfur atom is present in Na2S4O6, and their oxidation number also different. Oxidation number of sulfur which have SS bond is 0. So average oxidation number is 5 plus 5 plus 0 plus 0 divided by 4, that is 5/2. This is average oxidation number, not the actual oxidation number of each sulfur atom. The actual oxidation number is +5 and 0. Now see oxidation number of sulfur in caro acid. Caro acid means H2SO5. H2SO5, it is known as Caro's acid. So first you have to see the structure of caro acid. Structure is given here. In this compound, oxidation number, you have to calculate the oxidation number. Here two oxygen peroxide bond is present, so for each peroxide oxygen I have told the oxidation number is -1 for peroxide oxygen. So for 2 oxygen, this 2 oxygen -2, and for this 3 oxygen minus 6, 3 into minus 2, that is minus 6, and for 2 hydrogen 2 plus. Okay, so 2 for 2 hydrogen 2 into plus 1, for sulfur it is x I have assumed, for 3 oxygen, this 3 oxygen 3 into minus 2, that is minus 6, and for this peroxide linkage for each oxygen minus 1, so 2 peroxide oxygen, so minus 2. So total oxidation number of sulfur in H2SO5 is plus 6. Very important, you have to practice this calculation of oxidation number of different atom in a compound. You have to calculate oxidation number of chromium in CrO5, chromium pentoxide, CrO5. Oxidation number of CrO5. In CrO5, you can see according to structure, there are total 4 peroxide bond. 4 peroxide oxygen. So for each peroxide oxygen, oxidation number is minus 1. So 4 into minus 1 plus 1, for one oxygen atom it is minus 2. So 4 into minus 1 plus 1 into minus 2 plus x is equal to 0. So x is equal to plus 6. Okay. And oxidation number of carbon in C3O2, O2 in C3O2, these two carbon atom has oxidation number plus 2, and this carbon atom has oxidation number 0. Okay, now one more last example, oxidation number of each nitrogen in NH4NO3. In NH4NO3, two type of nitrogen atoms are there. In ammonium, if you dissociate this ion, this compound, you will get NH4 plus and NO3 minus. Okay, so you have to calculate the oxidation number of nitrogen in each ion. In NH4 plus, the oxidation of nitrogen is X plus 4 into H, for each H plus you have to calculate, you have to assume oxidation number of hydrogen as plus 1. So X plus 4 into plus 1 is equal to plus 1. Plus 1 is the overall charge of the ion. Okay, so X plus 4 into plus 1 is equal to plus 1. So X is equal to minus 3. So in NH4 plus, the oxidation number of nitrogen is minus 3, and in NO3 minus, the oxidation number of nitrogen, suppose it is oxidation number of nitrogen in NO3 minus is Y. So Y plus 3 into minus 2, 3 into minus 2 is equal to minus 1. Minus 1 is the charge of the ion. Okay, so Y plus 3 into minus 2 is equal to minus 1, then Y equal to plus 5. So oxidation number of nitrogen in this compound is, in this ion NO3 minus, is plus 5. Okay, so you have to practice the practice of calculation of oxidation number of different element in a compound. Okay, very important. Next day I will discuss about how to balance a chemical equation. Thank you, students.